Let us continue. We start with page number 3. We are going to discuss 3 properties of electric charge. Simple things. Today's 6 minutes, 7 minutes. Very simple one. The 3 properties are, we mentioned, additivity of electric charge, conservation of electric charge, and quantization of electric charge. What do you mean by that? First one, additivity. It means a body may be having positive charge or also may be negative charge. The total charge will be addition of the charges taking into account the signs. What does it mean? Or we say the charges are going to be, some charges are positive, some charges are negative. I must consider the positive and negative sign also. So when I put it in a sentence, I say the charge Q on a body will be Q1 plus Q2 plus Q3 etc. If there are n charges etc. up to n, what are Q1, Q2 etc. charges. So many charges are on a body, make the addition by using the signs. Positive sign is plus, negative sign is minus. Example, a body is given charges of 1E, E stands for charge of electron, 3E stands for charge of electron, 4E minus, and then let us say 6E. What E stands for? Charge of electron. E is charge of electron. It is same as charge of electron is negative, charge of proton is positive, but the value will be same. Its value is 1.6 into 10 raised to minus 19 coulomb. Unit of charge is E. So E is 1.6 into 10 raised to minus 19 coulomb is going to be the charge of an electron. If it is electron, negative charge minus. If it is proton, positive charge plus. So in this case, I am giving a body charges of plus 1E understood, plus 3E, minus 4E and 6E. What is going to be the total charge of the body? So in this case, and 1E, 3E, 4E and 6E are given. So a total charge equal to, everybody got mentally only, 3 and 1 is 4, plus 4 minus 4, that is 0, then 6E, charge of the electron is, so the body is going to be not electron, total charge is 6E. So I put it in a sentence, the total charge on a body is the algebraic sum of, algebraic sum means what? Taking into account algebraic sum, that means addition, algebraic addition of individual charges. That means positive and negative must be taken care of. That is just to understand. Additivity means make the addition of the charges with the considering the sign conventions in mind. Additivity. So the total charge on a body is the addition of algebraic addition of charges present. Second one is conservation. Conservation we studied in the school also. Conservation of energy. It means total charge of a given system remains constant. Maybe example, we are in a closed room, we are not in touch with the outside. Then in this isolated system, total charge remains same. In another language, charge cannot be created, charge cannot be destroyed. Charge cannot be created, charge cannot be destroyed. This property we call conservation of electric charge. That means suppose I say, if somebody says, I created a charge of 3, wrong. Why? Because nobody can create a charge, only I can transfer from one body to another body. It cannot be created, it cannot be destroyed, it can be placed from one body to another. So conservation means total charge remains constant for an isolated system or an isolated body. That means, or charge cannot be created or charge cannot be destroyed. Third one is going to be quantization. What is quantization? That property we want to study for the exam point of view. So what is quantization of electric charge? Once or twice they ask for the board exam point of view. Quantization of charge. Charge of a body we represent by Q. I can supply the negative charge means I can introduce 1 electron, 2 electron, 3 electron, n electrons. If I remove the electron also, I can remove 1 electron, 10 electron, 20 electron. Charge of the electron is E. The charges I can have on a body will be multiples of E, that will be n times E, where n is going to be an integer, 0, maybe 1, maybe 2, maybe 3, maybe 4, etc. This property we call quantization of electric charge. What is the meaning of that? It means E is the minimum charge that we can have, that is 1.6 into 10 raised to minus 19 coulomb. The other charges possible are multiples of that. It can be positive or negative, positive for positive charge, negative for negative charge. So I say it as, it can be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, etc. If it is plus, positive charge. If it is minus, negative charge. So what is the expression for quantization of charge? That will be Q equal to Ne. So another simple formula, Q is equal to Ne, where E is charge of electron, Q is total charge on a body, and N is an integer, 0, 1, 2, 3, 4, etc. If it is negatively charged, I will get minus. If it is positively charged, I will get plus. Out of this, what they ask for the exam point of view, what do you mean by quantization of charge? It means total charge on a body is an integral multiple of E, where E is charge of electron. What is integer? 0, 1, 2, 3, etc. are going to be integer. That means, if somebody says a body is having a charge of, let us say, 10E, minus 10E, possible. A body is having a charge of plus 20E, possible. But what about a body is having a charge of minus 0.5E? No, because it is not an integer, so it is not possible. So this quantization of charge, it has to be integral multiple. Now, you can have a charge of any number we can say. Now we are on 2020, so it is having a charge of 20E, possible. But a division of that is not possible. Only it must be multiples of that. Do we come across such a situation, quantization of any quantity in our daily life? Yes, maybe when you are playing, when you are in the field, football, we are having the goal, 1 goal, 2 goals, 3 goals, it will be multiples of 1. Basic one is 1 goal and multiples of that. We never come across a situation, one team scores 2.5 score, 3.5 goals, people will laugh. Similar is the case with the cricket. In cricket, people are scoring runs, 1 run, 2 runs, 3 runs, 4 runs, etc. Think about a situation. Our favorite batsman almost reached the crease. Shall we say, let us allot him half a run? No. So, life also, when our daily life also, some quantities are quantized, minimum quantity and multiples of that. So, can I have a score, charge of, let us say, 2.75E? No, because it is not an integer, it has to be an integer into it, quantization of charge. Then, what is how much one coulomb will contain? How to utilize the formula Q is equal to Ne? Can we say 1 coulomb of charge contains how many electrons? So, what is our example? It is illustrated in the notes. Example, E is going to be 1.6 into 10 raised to minus 19 coulomb. So, how many electrons are required in 1 coulomb? That means N is what? In 1 coulomb. Repeat, how many electrons are there in 1 coulomb? Use the formula charge Q. In this case, Q is going to be 1 coulomb is Q. So, Q is equal to Ne. Formula. Charge is 1 coulomb. N I don't know. E is 1.6 into 10 raised to minus 19. So, what is the value of N? 1 upon 1.6 into 10 raised to minus 19. 1 upon 1.6, that will become 0.625 into 10 raised to minus 19 will go up plus 19. So many electrons are there. If you want, I can shift the decimal. That will be 6.25 into 10 raised to 18 electrons are there. In 1 coulomb of charge, how many electrons must be there? How many electronic charges must be there? 6.25 into 10 raised to 18 electrons. That means if the charge is minus 1 coulomb. If it is plus 1, it will be 6.25 into 10 raised to 18. Don't you feel this is a big number? So can we have 1 coulomb by assembling means 10 raised to 18 electrons are assembled. It is very large charge. So you normally, our examples as we said, we will have small charges 10 raised to minus 3, 10 raised to minus 6, 10 raised to minus 9, etc. Small charges. Out of 10 raised to 18 electrons, that's point, if I remove 1 electron, it doesn't make much difference. That means 6.25 and then 18 more zeros. From that, 1 or 2 electrons are removed. Doesn't make much difference. It's just like maybe you go to the beach, we can see so many fine sand particles. If somebody removes 1 or 2, is there any much reduction? No. If somebody put 1 or 2 particles more into that, is there any much addition in the charge, in the number of what we call sand particles? No, we ignore that. So when the charge of a body is in coulombs, this quantization of charge doesn't come into effect. That means 1 electron less or 1 electron less, more, it doesn't make much difference in the case of large size bodies. Anyway, in our discussion, we consider small charges, so Q is equal to Ne is valid. Now, from today's discussion of charging by induction, then grounding, and then that page number 2 and 3, in short, what we require for exam point of view. Exam point of view, page number 2, we must have that idea. What is the importance, why we use earthing or grounding for our electric connections to protect the instruments from damage due to electric shock. Then we have to understand that diagram on page number 2, those diagrams, we have to understand what diagram C, D and D, what happens when the spheres are separated, what happens when the glass rod is removed, what happens when they are still separated. Understand that. And then, what do you mean by quantization of charge? Quantization of charge is the thing we introduced on here. Page number 2 and 3 are over today. You will go through the notes. But something is not clear, please mark, and with pencil we clarify. When we meet again, we continue next section next time. Thanks.